Hello data lovers, so welcome back to the third video of SQL Interview Pro series, and today also I am going to solve 4 SQL interview questions, and all 4 questions will be from the medium category. And for last 2 videos I'm pretty sure you guys have watched it and solved all those questions. If not, then check it right now and solve those questions immediately. And the questions which I will be solving today, you can find it on Code Studio platform by Coding Ninja, and these questions are free to access, so completely free for you to practice SQL question. I have provided the link in the video description. Like this video for the better reach, because I will be covering some amazing topics of SQL today. First, try to attempt these questions by your own. Put your solution in the comment section and then watch my solution. So let's start now and solve today's SQL questions. Okay, so this is the first problem for today, and the problem statement is apples and oranges. So let's look at the problem statement, input data and output data. So here we have a table named as sales. It has 3 columns: sale date, fruit, sold numbers. This is the primary key combination, and the data which this table has, basically it contains the sales of apples and oranges sold each day respectively. For each day there will be 2 entries, one for apples, one for oranges, the total quantities sold for them. So what we need to do, write an SQL query to report the difference between number of apples and oranges sold each day. So this is something which we need to count for each day and return the result table ordered by sales date in this particular format. So here we can see, 1st of May 2 entries, apples and oranges, apples 10, oranges 8, and for 2nd of May 2 entries, for 3rd of May 2 entries, for 4th of May 2 entries. So if we look at the data, right, we need to give the 4 rows, obviously one for each date, and the output should be difference of sold apples minus oranges. So if we look at this one, right, if we look at the explanation, for first row, which is 1st of May, it is 2 here, difference is 2, that means 10 minus 8. For second it is 15 minus 15, 0. For third it is 20 minus 0, that's why positive 20. For last one it is 15 minus 16, that is why it is minus 1. So by looking at this data and the kind of output we need to calculate, one thing is pretty clear, that we need to take a help from the window functions. There are multiple approaches. To be very honest, I have been saying this thing to solve a SQL question. There are multiple approaches for it, right? Even I can think one of the join approach here as well. Now you need to guess here what kind of join approach I am thinking here. So let's try to go ahead with the clean approach, which will be the window functions. So here we need to do what? We need to subtract this value, means the value for the oranges, with the apples. So by anyhow I need to bring this value in front of this one. So here we can use the lead window function. Lead window function just moves the column values by n steps. Whatever steps we'll be providing, it will move the value in the upward direction, right? So that lead function we will be using, and simply we can subtract it. This is something where we are calculating for the row where fruit name is mentioned as apple. There we are calculating the output. So we can simply put a where condition so that we are getting only one record for each day in our output. So let's try to implement that one. Select, and in our output what we need sale date and difference, right? So this is something which will be the part of our outer query, because in our inner query we are going to calculate this difference. We are going to apply the particular window functions. Okay, so from this, and here what we are going to do, we are going to write that inner subquery. That inner subquery will be like select star, comma, what we are going to do, we will use this value, current value for the sold num, minus whatever is coming from the lead window function. So sold num minus lead of, we are applying the lead function on this sold number by one step. right? So what will happen? And here we will be using the sale date as a partition value, correct? So this will be one partition, and inside that one, since we are using step 1 for the lead window function, so this 8 will move, like there will be a new column. That new column will be something like where 8 is moving here on top, right? It is taking a gap of 1 step, and in front of this row there will be null because nothing is below this value for this partition, right? So you can try it step by step. Just first try to execute this inner sub query on your console so that you can have a look at the output, right? The intermediate output, and then how this final calculation is being done. Here we will write the over clause over partition by, we will use sale date, and we will name this thing as diff, right? And here the table name is the sales, and after this one what I'm going to do, I'm going to give a alias name to this intermediate sub query. And now in my outer query, what I'm going to do, I'm simply going to put a where clause. Where clause, as I already explained, we need only one output for one record. So since in this particular row I am doing the actual calculation, and based on the input output everything is clear that only 2 fruits will be there, and if there are more than that, and if there is something different problem statement, this might be needed and this might not be needed, the where clause which I'm talking about, right? So where fruit equals to apples, and we need to also do it in the order by way, so order by sale date in ascending order. Okay, so now if we simply execute it, so here we can see our output, that thing we were expecting it, like diff 2 for 2nd of May it is 0, for 3rd of May it is 20, and for 4th of May it is -1. So let's move on to the second question, and this is our second question named as count salary categories. Okay, so what is the problem statement here? Let's try to look at it. So here we have a table named as account ID and income. Account ID is a primary key. Each row contains information about the monthly income for one bank account. Okay, so what we need to do, we need to write a SQL query to populate this kind of output, which is like result table. So here we need to derive 2 columns. One is category, second is accounts count, and here we need to derive these values. Low salary, all the salaries is strictly less than 20,000, and salary which are between 20,000 to 50,000, right? That we need to derive it as a average salary. Third is the highest salary, means is strictly greater than 50,000, right? So here this is the input table. You can see, right, account ID 3 is something which we can see greater than 50,000, so this is high salary. For account ID 2 it is less than 20,000, so this is low salary. For account 8 and 6 both are greater than 50,000, so both will lie into the high salary range. So even in the output, right, what we can see, we need to just do a count, right? How many accounts are there which falls under the low salary category? How many accounts are there which falls under the high salary? How many accounts are there which falls under the average salary category? So based on this derivation, we definitely can see there are no accounts as such which lie under the average salary category. That is why this value is 0, and for rest of the 2 it is 1 and 3 respectively, right? So that's what we need to do here. And as I said, there can be multiple approach for this one as well. One approach could be like we can simply use a case when statement, right? We will use this input table and we will derive one more column here named as category, right? And there what we will be doing, we will be doing the simple case when statement to populate these values in front of, or basically within that category column. And after that we can simply take a group by on that derived column and for each group value we can apply the count star and we will be done. But there will be a catch. So even if you look at this table, right, if I try to derive a new column name as category, so at that moment or only for this data set, there will be only two values. One will be low salary and the high salary, because there is no record as such which satisfies the condition for the average salary. Take a group by, right, in your output only two rows will be there, low salary and high salary, and you need to take care the entry for average salary in the resultant table explicitly. You need to do some kind of join, some kind of extra addition in your logic in order to get this one in your result table. Here I'm going to take again a neat and clean approach using the union operation. So one by one we will write three queries and take a union of it, and we will try to derive these two columns in each of the query. Each query will have a different filter condition and respectively it will be doing the count for the same, right? So let's try to implement it. Select low salary as category, because this is a condition for union operation. The sequence of the column should be same. So low salary as category, and after that we will use this count star and we will name it as like accounts count, right? And here we are selecting everything from this accounts table, and this one, right, this value we are deriving for a different filter condition. That's why I was saying we will write three SQL queries and we will just do the union operation, and each query will follow a different filter condition because we need to derive it accordingly based on these conditions. So here the condition will be where income is strictly less than 20,000. So this is the first one we have written, and after that I am going to use the union condition, right, and my second query, and again a union operation and third query. So for second one what we need to apply, we need to derive it as a average salary, and the condition for average salary is inclusive range, means greater than and equals to 20,000, less than and equals to 50,000. So here this will be changed to greater than and equals to 20,000 and income less than equals to 50,000. For the last one, which is the high salary, how we will derive it? High salary as category, count star as accounts count, and here it should be strictly greater than 50,000, right? So let's execute it and verify our output. Oh, there is a typo mistake, my bad. So this should be less than 50,000. Really sorry. Why the output is different? Okay, the typo is this should be greater than. All right, let's execute it one more time. Cool. So that's the expected output we are getting here. Average salary 0, low salary 1 and high salary 3, right? Whatever we were expected to get here. So let's move on to the third question, and the question is all the pairs with the maximum number of common followers. I see. Okay, cool. So let's understand the problem statement first. We have a relations table. It has two columns, user ID and a follower ID, and this combination will be a primary key. So let's try to understand what this data contains. Each row of this table indicates that the user with ID, follower ID is following the user with ID, user ID. All right. We need to do what? Write an SQL query to find all the pairs of users with the maximum number of common followers. In other words, if the maximum number of common followers between any of two users is max common, then you have to return all pairs of users that have max common number of followers. Pretty much understood. And what our output should look like, the result table should contain the pairs user 1 ID and user 2 ID, where this value will be less than this one. Return the result table in any order. Cool. So this input table looks like a table from a social media application, simply like the Facebook, Twitter, Instagram. Here we can see if this is a user and this is the user ID 3 which is following this user, right? So if we look at this data and we want to identify how many followers this particular user 1 has, so we need to just look at the entries for this user, right? So 3 follows 1, 4 follows 1, 5 also follows 1, right? So total 3 followers for user ID 1. Okay. Similarly for 2, 7. So in this way, if we try to create the distinct pair of users, right? We have 1 as a user, 2 as a user, right? 7 as a user. For just user ID column, if we try to create the pairs, right? So each pair might come up with a different value for the common followers. And here we can see the explanation. So if we try to create a pair of user 1, 2, right? Both are different user. And we try to see how many common followers these two folks have, 1 and 2. They have 3 and 4 as a common follower. We can see 3 follows 1 and 3 follows 2 as well, right? So it will be counted as one common follower for this pair 1, 2, right? And similarly 4 also follows 1 and 4 also follows 2. So in total we can say for a pair of user 1, 2, it has only 2 common followers. Similarly for 1, 7, 3 common followers. For users 2, 7, we have 2 common followers. So based on our problem statement, first we need to calculate something like this, and after calculating this kind of intermediate output, we can see among these common follower values, one is 2, one is 3 and another is 2. What is the maximum value we got for the common followers? That is 3, right? 3 is the maximum number for the common follower value. So there might be other pairs as well. There might be other pair of users as well who might be having the same common follower number, exactly like 3. So that is something which we need to calculate, and in our output, right, 1, 7, 7, 1, right, both are same in the form of the pairs, right? But here we will not be doing the same computation for 1, 7, 7, 1 because output will be same, and as per the problem statement in our output, we need to print our pair where this value user 1 underscore ID should be less than this one. First, I will perform a join operation. Obviously, the self join kind of thing is definitely required here. Okay. So after doing the self join, I will be able to find the common followers, right? And once that count of common follower is identified, I can simply apply a group by on this user 1 and user 2, and we can do that simple count operation, or the way we simply do that highest salary within a department or within an employee table kind of operation. Okay, so first let's try to write a common table expression, means iterative common table expression or with clause, which will hold that intermediate output which I was talking about. Okay, so with, we can say follower count as we can say like select, right? Let's keep it as it is. I am not going to write what column we are going to select here as of now. As I said, first we will focus on our join conditions, how we are going to join it. And as I said, it will be a self join. So from relations table, right, this is the first one, I can name it like T1, and I want to perform a inner join. Why inner join? Because I need to focus on the common followers. So if I have this table on the left hand side, same table on the right hand side, okay, I will be doing a join operation on this follower ID value. So inner join with the same table, and we will give a different alias to it, right? And inner join to on T1 dot follower ID. Okay, T1 dot follower ID equals to T2 dot follower ID. Okay, and we also want to add one more condition so that we can get away from this kind of operation, right? 1,7, 7,1. So while joining this condition, obviously this common match will be seen, but in the same time all those pairs will be discarded where this kind of condition comes in, means user or this value becomes greater than this value. So how can I deal with that one? And T1 dot user ID should always be less than T2 dot user ID, right? In this way, within one join condition, I am going to get the common follower count for one specific pair, and I am also discarding its another version, means A comma B, B comma A. So I am discarding B comma A. Okay, so inner join part done here. Now in the select operation, what we need to do, we need to derive these two values for sure, right? So whatever is coming from the left hand side, I will name it as a user1 ID. So select T1 dot user ID as user1 ID. Okay, and select T2 dot user ID as user2 ID, and I'm also going to take a count star as common follower count. The intermediate output, it would have looked like this: 1,7 and the join follower ID, which is 3, right? And after that, what would have happened, right? It would have looked like 4. It would have looked like 5. So now if I want to calculate how many common followers 1,7 has, so I need to take a group by for these two user IDs together and just do a simple count star. That's what I have done here. So first I have taken this count star, but I need to mention this group by condition here as well. So group by, right, T1 this and T2 this. Okay, so in this way our intermediate output is prepared here, right? So now if I simply run this query, right, I simply use this one because this is our common table expression and we can use it. And if I simply do this count star and we try to check how this intermediate output looks like, right? So here we can simply see that how this intermediate, this is the intermediate output we have, correct? User1 ID 2,7 common follower count 2, right? These are the actual pairs we wanted to derive: 1,2, 1,7, 2,7. Now we only need to put this thing in the final result. So how we can do it? As I said, simple fundamental of that highest salary thing we will be using. So select user1 comma ID comma user2 comma ID from this intermediate table where common follower count equals to select max of this thing, because there could be other pairs as well, right? There could be other pairs. So by any chance, let's say 2,7 was also having the 3 as a common follower count. So we needed to bring 2,7 as well in our output. That's why this kind of condition we need to apply, where for each intermediate common follower count, we are checking whether it is equivalent to the maximum value of common follower count. If it is yes, that means we need to include that pair as well in the output. Okay, so from this table. Okay, and now if we execute it, we should be able to get our final output, which is expected here. User 1 ID 1, user 2 7. Cool. So I hope now this is also clear. It used all of our fundamentals, the common table expression and the join operations, right? How to even put the conditional joins, all those fundamentals we have covered in this question. Now let's move on to the last and final question for the day, and that is the latest login in 2020. Okay, so let's understand the table. We have a table named as logins, and it has column name, which is user ID, timestamp, and this is our primary key. So this looks like a simple application website where you have created your own account and you can even log in onto that platform infinite number of times. And each time when you log in on a platform, obviously one entry will be created in a login kind of table, that at which particular point of time you again logged in back into the application. So that is the kind of data it has. So what we need to do here, write a SQL query to report the latest login for all users in the year 2020. Means in the year 2020, what was the last time they logged in into the platform? That is the thing we need to calculate here. We need to return the result table in any order. Also, do not include the users who did not log in the 2020. So if we look at this data, right, we have user ID 666. So we can see 3 timestamp entries have been created here. One for 30th of June 2020, and then 21st of April 2021, then 7th of March 2019. As per the problem statement, we need to only check the latest timestamp or the latest login for the year 2020 only for all of the users. So this record will be the eligible for this user ID login record, and that is something which should come as a last login time for this user. Same for user ID 8, we can see 2 entries for 2020. One is basically 1st of Feb, last is 30th of December. So latest login this guy made on 30th December, and that is what we can see here. Okay, now for user ID 2, we can see 2 entries, 2020, 2019. We will definitely discard 2019. We will try to identify the latest login time only for those timestamp entries which belongs to 2020 for each user. So that is the thing we need to do, and as per the result we can return our output in any of the order. No specific order here maintain. Alright, so let's try to write the query. Very simple. What we need to do, we need to use this timestamp value. Okay, and in this timestamp value, we simply need to do the max, right? We need to use the max on this particular column, and in a group by, I can simply use this user so that there is only one record in the output for each user. So on a user level, group will be created, and within that group, I am supposed to count this thing. I am supposed to count this part, right? The latest login time. Okay, and latest login time. So after that, what will happen? We need to apply the where clause as well, where we will try to extract the year value from this timestamp value, and we will try to equate it with the 2020, whether this timestamp falls in the 2020 or not. Okay, so that's the simplest thing we need to do here. So let's write a query for it. Select user ID, comma, max of time stamp, and we will rename it as last stamp. So here the table name is logins. Now at this moment you might be confused what we should apply first. We should apply the group by here, or we should apply the where clause here. So definitely makes sense to apply where clause before the group by, because this is a common fundamental for optimizing your queries. If you apply the where clause before, that means you will have a less data to compute in the group by operation. If you do it on the group by, first of all your result will be incorrect, and also you are doing the complex operation and time taking operation first, and then you are filtering out, and it is definitely not an optimized query. So now we will write our where clause, and for that one we will use this function extract year from this value, and we need to make it equivalent to 2020, okay, because that is something which we are supposed to compute. And after that we will apply group by on user ID, and let's execute it. So this is the output we are supposed to get here. So that's what I had for you guys in this video. I'm pretty sure you would have enjoyed all these 4 questions, and you will try to attempt it by your own and put your solution in the comment section. And after that, try to look at my solution and my approach. And if you have anything extra you want me to cover in upcoming video of this SQL interview question series, put it in the comment section. Like this video in the big numbers so that these kind of amazing question can reach to maximum number of data professionals, and they can also prepare themselves. And I will see you guys really soon with the part 4 of this series. So stay tuned, and till then keep exploring data.